What's up everyone, my name is Nick and welcome back to Digital Manufacturing and Design. Today we're going to take a look at this SolidWorks part file that we just finished up. It's going to be for the NIMS part number 98431. And we're going to pretend like we didn't have this engineering drawing and this blueprint to reference drawing this part. And we're going to go ahead and create a 2D drawing from this as if this didn't exist. So it's very important that we know how to make 2D drawings, because if you go ahead and try to say that I want to manufacture this, you need to communicate with somebody the critical dimensions or how it needs to be manufactured. So you got to know how to create a 2D drawing, blueprint, engineering drawing, whatever you want to call it. So the way that I do that is, if you guys remember, if you go up to File, New, when you're starting a new SolidWorks part, you're prompted with whether you want to choose a part, an assembly, or a drawing. We just finished up the part level. We're going to go into the drawing level, but I'm not going to hit OK here. I actually want to link the part file to the drawing file. And the way that I do that is I go to File, and I make drawing from part. So again, File, make drawing from part. And I already got a drawing that has the same name, so I'm going to hit No. You guys probably won't see that on your end, but I'm going to be prompted with, or you're going to be prompted with, the sheet format size window, which is going to ask you what size that you want to make this drawing, or this 2D drawing from your part. And you can choose between an A, B, C, D, and there's a whole bunch of stuff here. And that's just going to be the different sizes that you have, because if you look at engineering drawing sizes, an A sheet is an 8.5 by 11, B sheet is 11 by 17, and so on and so forth. ANSI is going to be our draft standard. I'm just going to select a ANSI standard, which is just going to be a basic 8.5 by 11 sheet with an ANSI drafting standard. Now you're going to notice that the layout, or the format that we're looking at, is going to be a little bit different than what we're used to seeing in the part level that we just finished drawing, that 98431 part. Typically we had the sketch and the assembly tab up here, and that's where we're jumping back and forth. You got the sketch for the 2D, and then you got the features for the 3D. In this case, you're going to still have your sketch tab here, but it's not going to be the first and foremost thing that you see. But what we're going to be dealing with the most case is going to be annotation and view layout. You're going to be jumping back and forth between these. Your view layout are going to be extended views that are going to be projected from these initial projection views. This is over here is called the view palette. These are specialized views inside that view layout, where you're going to have like section views or detail views or call-out views. And then your annotation tab is going to be everything that is going to be related to notes and dimensions and things of that nature. But you're going to be jumping back and forth between these two a bunch. You're also going to be pulling up this view palette a whole bunch as well. So just familiarize wherever this is located. There's going to be a little icon here with a bunch of little Lego pieces on a piece of paper. Again, that's your view palette. It's going to be on the right side here. When you click off of it, it's probably going to disappear. But you just got to make sure that you keep opening it up for every new view that you want to be pulling out. So in this case, again, I'm going to be looking over here at our initial print. I'm not trying to recreate this exactly. I'm just trying to show you how to create something somewhat like it. I'll show you how to do the critical dimensions. I'm not going to go into every little detail here, but it looks like the first and foremost view that we're going to be looking at is that top view. So I'm going to take this top view right here in the view palette. I'm going to click on it. I'm going to hold it, and I'm just going to drag it out here to the piece of paper. And you notice that's going to be projecting, and it's going to continue projecting that view wherever you move your mouse, unless you hit the green check mark or you hit escape. You see how it's giving me a right view, and then it's giving me a front view, and then an isometric view as well. It's going to keep doing that until I click, or I hit escape, or hit the green check mark. When I click, it's going to place that view. I don't want to do that right now, so I'm actually going to hit the green check mark and just tell SolidWorks that's all I want to see. So again, we're going to be trying to recreate the drawing that we're seeing here. It looks like the next thing I'd probably get into as far as views go is this view down here. And don't be confused, because that's not technically a front view. That is technically a section view or a cross section. And we can tell that difference because it has the cross hatches inside of the part. And we're going to look at the section AA, which is going to be section A. And it's a little bit goofy because it cuts through a whole bunch of pieces of this part, and it's a really good representation of what we can see through the part, as if it was like cut on that cutting plane there, because we can see all the holes and slots. But it's a little bit difficult to draw that inside SolidWorks. I'll show you how to draw a basic section view, and I'll show you how to actually draw this complicated section view as well. So first and foremost, if I go over here to my view layout, I can take my section view, and I can be prompted with either a vertical cutting plane, a horizontal cutting plane. I can also get these specific ones where it's aligned or auxiliary. half section where I can either cut like a little part of it. You can see how it's projecting on my screen here. None of those are actually going to solve the cutting plane that I see on this drawing here, but just really quickly, if you ever wanted to draw like a basic cutting plane, I'm just going to select this horizontal one and have it intersect one of these slots and one of these holes. If I click on that point, I can hit the green check mark, and you can see that I have a pretty decent section view. It's not getting these other holes here because you can see that that line is not going through it. I can also change the direction of this by clicking on the section view itself and then clicking on the point of the arrow, double clicking on it so it goes the other way. I'll have to rebuild it if I want it to flip. But I'm not going to deal with that one right now. I'm going to show you guys how to draw a more complicated one. And this is a little bit frustrating because we're actually going to have to draw this by hand with the sketch tool and the line tool. So what I'm going to do is I'm going to take this line tool, and again, you have to go through all these holes. And the best thing to do here, because you want to, looks like you want to include everything or every part of that hole, is we're actually not going to start from the center mark of that hole and move over. I'm going to kind of work backwards here, zoom in a little bit. I'm going to select the most right point of the hole and then drag this out like that. And then I'm going to hit escape, and I'm going to keep hitting enter and escape. So enter is going to cancel, continuing drawing a line. Enter is going to actually restart the line. So I'm going to hit enter here. It's going to prompt the last command. The thing that I'm going to do here is just, again, I hit escape, hit enter. I'm just going to try to create some kind of line format here so I can come back and eventually trim this up. So just hitting enter and escape accordingly. When I want to finish a line, I'll click and hit escape. When I want to start a new line, I'll hit enter. So I'm just working my way backwards here and having it intersect these lines. And that should be pretty good for me. I just have to then click on this line again to kind of wake it up. And then I got to go over here to trim the entities. I'm going to use my power trim. And I'm just going to extend these lines and then trim them accordingly. Some of these are going to stay blue, and I think it's just because SolidWorks is going to be stubborn about it. I can always click on these and associate relationships. It looks like there's already relationships. I'm sure it's just something goofy. So for example, that line just doesn't want to be on the center mark. Just drag it off and then try to wake up a center point. Maybe I have to put a point there. It's not wanting to snap for me. That's fine. It's just being a pain in the butt. Coincident. There you go. It's locking down. I'm not going to spend all that time trying to make this perfect here, but I'll actually have to go back into my annotations and put a new center mark there just because I accidentally deleted it. But you get the point. I'm not going to spend too much time trying to make this completely perfect. I'm going to click on this line, right click it, and then go select chain. And I'm going to go over here to my view layout and select section view. And what's going to happen is you're going to be prompted when you draw one of these lines if you want to create a legacy foreshortened section view. And that's what we want to do. This standard section view is actually going to take this line and it's going to continue like projecting over it. We actually don't want that because it's going to make it look like the part is longer than it is. So I'm going to stick with this legacy foreshortened section view. You're going to notice here that it looks a lot closer to what we were looking at here in the initial engineering drawing that we were referencing. So I'm also going to throw in a couple of other views here. Typically when I create drawing views or drawings or 2D prints for people out on the shop floor, I try to include an isometric view, and that just makes it a little bit easier for people to perceive and understand because, I mean, you're looking head down at this. I don't really get the whole picture. I might actually want to see or represent a little bit different of a view here with the isometric view. So I'm going to open up my view palette again here on the right side. It looks like the view palette is out of date. I'm just going to hit the green check mark. Sometimes it does that, it loses its connection temporarily. And then I'm just going to select the isometric view, and I can drag it out like that. I'm going to click on this and I can change its size because I think it's a little bit too big because I need to include my revision table and other information as well. And what I can do is I can go over here once I click on it and I see this blue bounding box around it. I can go to scale here on the left hand side and I can choose a custom scale, and I can make it a little bit smaller. Let's make it 1 to 2. And then I can also change the display style. So just like how we can change display style inside of a part file, I can either go up here to the little blue box here and change my display style this way while this is selected, or I know this is selected because I see this properties bar. I can just change it in here on the left-hand side as well. So I'm just gonna make it shaded with edges, and that's just a little bonus here. Give some people a little context when they're manufacturing this in the future. I believe I can probably start making some notes and callouts as well as dimensions here. So I'm going to flip over here to the annotations tab from the view layout tab. I'm going to go here and I'm going to go smart dimension this, and I'll just use the smart dimension tool just like I used before in a regular part file. I just have to click on the edges that I want them to be smart dimension. So I just want to display that that is 3.5. I can make this one 2.5. The thing that you'll notice that's different from a part level smart dimension tool to a drawing level smart dimension tool is that when I double click on this, I can't change the dimension. It's not reactive. So if I ever wanted to change these dimensions inside of the 2D level, I have to actually go over here to window, and I got to go to that part itself, or I can right click on the part. I escaped a couple times. Right click on the part, and then I can open the part and I can edit it that way. So for example, we said that this was 3.5 on the drawing. If I wanted to change that to say 4.5, add an extra inch to it, you'll notice here that when I make this dimension change, and I hit exit sketch, rebuild the part, it's gonna take a second. I can either go up here to window and then jump back over here to the sheet, or I can hit Control Tab. You'll notice it's gonna give you a couple warnings that the drawing is updating. You'll notice that the drawing has updated. So that's pretty helpful because if you've ever worked inside of a 2D CAD software like AutoCAD, if you make those changes, you pretty much have to continue trimming that stuff up and extending it with the miter line, so on and so forth. It makes it a little bit difficult, especially when you have dimensions that are already placed. SolidWorks is a little bit more reactive, where if you make a change, it updates automatically. I'm actually going to undo this because I don't want my part looking a little goofy. Just hit Control Tab and just Control Z, edit, undo. And I'll flip back over here, Control Tab. And no harm, no foul. It went all the way back to what it was. I'll show you how to add a couple more dimensions. I can start up that Smart Dimension tool inside the Annotate tab. I can go over the overall total height. First thing that I notice is that says 0.73. I want that to display as 0.725. The easy way to do that is if you go down here to the bottom right-hand corner, you can see that there's a little icon here that says IPS. I can actually open that up, and that's going to open up my edit document units. I can click edit document units, and it's going to show my document properties. And this is the same thing as going up here to the gear and then going over to document properties, but I'm going to change my units here to 123, 123. That's going to be linked to the actual part file. If I go here to dimensions, I'm going to change that to from 2 places to 123. I'm going to hit OK. And you'll notice that this is going to update the part. So if we go, again, I'll show you that. System options, it's the same thing as going to that IPS and editing the document units. I was in units, and this is going to be that 2D level, or sorry, that 3D level. And if I go over here to dimensions, that's going to be your 2D, your drawing. So I changed that to 123. Now I can see that as 0.725. I can add another one here. 0.3, move this down. If you want to add radiuses or radii dimensions, you can grab these arcs with the Smart Dimension tool, and you can see how that's projecting out like that. Let's see, if I wanted to get a diameter of something, I could just grab the absolute diameter of it. I'll get my diameter dimension. I can also get angles the same way that I get angles inside of a SolidWorks part file. Just grab the line and grab the other line. Might have to play with it a couple times. kind of move my mouse around to get that 40 degrees. And I can just go around and do things like that. If I wanted to go ahead and start adding datum points, because it's going to be important for us to create datum points when we're giving this off to somebody to manufacture, because those datum points are going to communicate work holding checks. So for me, I'm just going to worry about making an A and B perpendicular right now. That's going to be kind of relative to this EC. So the way that I do that is I'm still inside the annotation tab. If I go here to datum feature, and click on datum features, and it's going to start up a new datum for me. And all I have to do is hover over the line that I want to place that datum. So this is going to be vertical. So I'm just going to select that, and it's going to flip it into the vertical dimension, and then it's going to keep prompting the next letter. I'll select this horizontal line. I'll get the B dimension. And the nice thing is I can hit escape and reposition some of these lines and kind of give some space here. Just all I have to do is click on it and drag it. And I can change them as I see fit. So for example, if I wanted to change this letter to E and this one to F, whatever it was in the print, it was E and C. I can always double click or single click on this and open up the options tab for these datum points and see where it says label setting. I can change it to, let's say I'll make this F, and it's going to update to F, but I'll just keep it to A. And the same thing with the section view, because I created one and I created a second one, so it prompted it to B. I can click on the section view and I can change it to A, and it'll update both of those as A, and then it'll also update this drawing down here to section AA. But with my datum point, I have to associate that there's going to be a perpendicular value that's related to both the A and B dimensions, or the A and B datum points. So I've selected datum point feature. I've finished that up. I'll hit escape a couple times to get out of it. Now I'm going to go to geometric tolerance, and it's going to open up the geometric tolerancing window. All I have to do is choose the symbol that you want to showcase. So for me, I'm going to make sure that it's the perpendicular symbol, and then the primary. So if you guys remember your 1, 2, 3 rules for your datums, you have to have 3 datum points to kind of create a part that doesn't rotate in space. So you can select those 1, 2, 3, but sometimes it's just okay if you just have 1 datum point that you're calling out, or just 2 datum points. Here I'm just going to have 2. Just have A for my primary, and then I'm going to type in B for my secondary, and then I can choose my tolerancing. So I'm going to make it 0.005 or 5 thousandths, hit OK. And then it's going to drop a datum or control line for me. It looked like it dropped down here for some reason. It was like hidden there. You might have to zoom out a little bit and see where it dropped, and then just drag it into its correct location. So that's a pretty easy way to put in datums there. Let's see. I'll also show you guys how to add in this revision table. So I'm going to actually select this view here, this isometric view, and I can grab the bounding box and then move it around. Go up here into the annotation tab. I can go to tables, and then I can select revision table. And it's going to give me a basic revision table. I'll hit the green check mark, and it's going to just plop a pretty basic revision table there. You can edit this just like how you edit something inside of Excel, where you can right-click on the columns or the rows and add them and remove them as you see fit. You can also grab the corner points of it and just reshape it, resize it so it's not hanging over itself. I'll just leave that there. And then if I wanted to prompt a revision, so if somebody said, you know, we got to change the surface finish on this, I can always click on this little arrow with a B next to it, and it's going to prompt a new letter, and it's going to come up with A. And like, for example, I'm just going to say that, you know, this edge here, we change the surface finish of it, and you're going to keep putting down revision marks until you hit escape, just like other things here inside of SolidWorks. But just make sure that, you know, you have in revision A, description, I'm just going to say updated, just updated surface finish. And then just put your name on, against it, so approved. Put like NB, your initials, click off of it. And this is also pretty nice because it's telling you what zone it is. So inside this specific ANC sheet, it has a B2, B1, A2, A1, and it's just telling you that the change that's being made is in zone B2. And you're going to notice here too, this A dimension, or this A datum point, is within inside of a square, and this A revision is within inside of a circle, and then this A section view is connected to arrows. So while there are 3 different A's that are on the sheet, because they're being displayed as whether they're inside of a box or whether they're inside of a circle or whether they're connected to an arrow, they're all going to have different display features that are associated with them. So just keep that in mind. I'll also show you another view that you guys can add here as well. I'm going to hop over here to the view layout. This is really helpful if you have a lot of components that are within the part or like within its cross section that are really hard to see. So if you guys use this detail view, it's actually going to be like a little magnifying glass. So I'm going to select on that detail view, and it's going to like ask you to draw a circle, and you just have to drop that circle. I prefer not to lock it to any lines or any points, just because if I ever want to move it, it's kind of hard to undo that connection point. So I'll just kind of free draw this out here, or just drop the center mark of that circle and then just drag this out. And you're going to get a nice little detail view, which is going to be a magnified view of that area. So for example, if there was a thread there and you wanted to call up that thread, but there wasn't enough room to put the note there or put the proper dimensioning there, I can put a detail view right next to it or right over it. I'm also going to escape a couple times. I've already dropped it. I'm just going to replace this so it's not overlapping itself. Do something like that. I can give a hanging leader here with the C dimension. So this detail C, I'm actually going to change it to detail B. So all I did was I selected that C, and over here on the properties, just like how I would change the letters for the datums or the letters for the section view, I can go over here and just change it to B on the left-hand side. And you'll notice that it updated already to B. I can also change its leader. So see how it says per standard? I'm actually going to change it to with leader. That's just going to give a little hanging leader with it, a little flag out for the B. So just calls that out. And then I'll just select on this detail B text and just drag it up there. I can also add notes here as well. So I'll just move some of these views out, something like that. And if I wanted to put some notes here, just like basic general notes, all I would have to do is go up here to annotation, and then I have to find the note, which is the letter A. I can just put a note down here. So I can just type in, this is like a free hanging paragraph where I can just type in notes and hit the enter key, and I can put 1. I could say deburr all sharp edges, and then note number 2. I can put polish or anodize. And I can just put stuff like that. That just makes it a little bit easier. It's going to keep prompting to put notes until you hit the escape key. It's going to keep repeating that note. So I can just put that notes right there. And I can do the same thing if I wanted to put a title as well. So I can go to my notes tab or notes feature here, and I can just put NIMS 98431 drawing. You notice here that the drawing number is actually linked to the drawing or the part level that we created. So whatever you saved your part as, so we saved it as 98431, that's what the drawing number is going to come up as well. I can save this really quick, but I do want to jump in here and change something and add some layers. So I'm going to go in File and Save As, and it's going to ask you if you want to update this. I just don't want to lose any progress before I go into this next step because it might be a little bit complicated. I'll just name it 98431. I'm going to override a file that I already had saved for that. Save it all. And again, you're noticing that I'm not doing all these dimensions. I'm not doing every single call out or notes or feature or every single revision block table. I'm just giving you guys a basic idea of how to do that kind of stuff. And you'll notice that as you work with parts, as they go through revisions, as you make changes, you are going to see this kind of grow in scale and complexity. So just take this with a grain of salt. I'm just showing you the basics right now. And I'm going to show you how to create layers in this. So if you guys are familiar with working with 2D drawings, typically when you're working inside of like an AutoCAD format, you have to select what layer you're going to be on before you start drawing. SolidWorks is a little bit more friendly in that case because you notice that we didn't even have to select a layer to start putting views out, to start putting drawings on. We just started just dropping things in and going forward from there. So if I ever want to go back and add layers inside of a SolidWorks drawing, it's pretty simple because all I have to do is open up my line formats and then just add a new layer and then select the drawing or select the part level and then add the layer to that part level. And I'll just show you how to do that right now. So I'll hit escape a couple times, make sure that I'm out of everything. My line format looks like it's already up here just because I'm running inside SolidWorks a handful of times. But if you're opening up a blank SolidWorks, blank template, you're going to be looking for that line format. So all you have to do is just right click on any gray area inside of the toolbars areas. So up here, I'll just right click. I'm going to go to toolbars and I'm going to select this rainbow with a couple lines above it that says line format. So I'll select line format and you'll notice on the bottom left hand corner, it's going to show up with this line format toolbar. And what we're going to do is we're going to select the layer properties, which is going to be the stack of manila envelopes in blue. So we'll click on that and it's going to open up the layers. And this is starting to look maybe a little bit familiar if you guys were working inside of a AutoCAD format, but all we have to do is hit new and it's going to prompt a new layer for us. And I'm just going to name this part. And then I'll just click off of it so it saves it. And I'm going to change the color to red. So I just selected that black box that was located right there and I just selected red. And all I have to do is hit OK. Now, the problem here is how do we apply that to the selected lines that we want? Typically, again, if you're working inside of a 2D AutoCAD format, you'd have to select every line that you want to change, which is kind of a pain in the butt. SolidWorks is a little bit more forgiving in this case because all we have to do is hit escape a couple times, make sure that we're looking at the feature tree on the left-hand side. So we still have the feature tree, just like how we had the feature tree inside of the part level, but we're just going to look for any part that's going to be inside the feature tree. So for us, that's that 98431. We just have to look for the part icon symbol, and it can be either one of these, any one of them. And I'm just going to right click on it, and I'm just going to go down here to component line font, click on that component line font, and it's going to open up this new window, and it's going to say use document defaults. I'm actually going to deselect that, and I'm going to go for all views. I'll make sure that it's selected all views because I can select one of these part levels and I can just change the layer of that singular view. I actually want to have it to be applied to all the different views here. So whatever is associated or linked to that part, I want to change. So I'll select all views and this layer, I'm going to go to part. So we added that, and then when I hit OK, in theory, it should change red. So you're going to see that all of my parts inside of my drawing here that were associated to this part level and that layer are going to update with the red color that we created, which is really helpful because I'm going to save this again. If I ever want to import this from a reverse engineering standpoint, somebody can either turn off or turn on layers, and it's going to be really advantageous for somebody if they want to just remove all of the dimensions and they just want the drawing itself, and I'll show you why. So I'll also file save this as a DWG. So this is more of that native 2D drawing file format. So if I select the save as file type, I can go down here to DWG, and it's going to be overwriting this file that I already created. That's going to be fine. I'll hit yes. And what's nice about this is when you send out DWGs, you can send it to somebody as if it was going to be for quote, or if you were going to send it to somebody if they just needed to open it up quickly and they didn't have a 3D modeling software on their computer. This is really easy to communicate with or across organizations. I'm going to go to my flash drive and actually open up that DWG that I just saved out. So here, that DWG, that 98431, if I ever went to double click on this, so if I was opening this up from an email or somebody in the organization, as you open it up, you're going to see here that this is a very basic representation of the drawing that we had. We can see that the part is now red, and that's really helpful for somebody who might be just opening this up and everything is black and white lines, and it's kind of hard to differentiate between something. But it's pretty good because anyone with the eDrawings viewer or any kind of 2D drawing viewer is going to be able to open this. Likewise, let's take off our drafting cap or 3D CAD designer cap, and let's pretend like we're like a plant manager or somebody who's going to quote or manufacture this part, and they're just receiving these from an email. So I'm actually going to close this down, close out of this part, and I'm going to open up that DXF, or that DWG inside of the SolidWorks file format here. So I'm going to go to File, Open, and I'm going to look for that DWG. I'm going to open that. I might have to change my file type to all files if I need to find that, but I'm just select Open. You're going to notice here that if I wanted to create a new SolidWorks drawing from it, I'm actually going to not do that. It's going to bring us back in that 2D session, but I'm actually going to bring this into an import as a new part, as if I was going to recreate this or re-engineer this or reverse engineer this. And I'm going to hit Next, and you're going to see here that I have all my layers, and you can see the layers here on the left. I can actually select selected layers, and I can turn off, see that 0 layer, it got rid of all my format, I got rid of all my borders, and then this format here, nothing was linked to that, but if I turn off that part, I have nothing left, but I can take that part, I can hit Next, Finish, and we can explode the blocks. You're going to notice here that that drawing, as long as it's 1-to-1, it's going to be projected as reference lines here inside SolidWorks. And this is really helpful because if I ever wanted to reverse engineer it, all I have to do is, I'll have to right click it, make edit sketch, but all I have to do is edit the sketch, and I can go to Features, Extrude Boss Base, and I can just extrude things and create them as if they were a solid part. This is kind of a crude way of looking at it, but it's just helpful. You can notice that I don't have to even put in any dimensions, and it's just going to extrude things as such. And I do this a lot too if I ever just need to do something quick, if I need to just take a profile of a forging, or if I need to take some kind of reference file and then revolve it or extrude it. I'll just open the DXF or request for a DXF or DWG, and I'll just bring it into a SolidWorks format. And I don't have to dimension it all perfectly, and I'll just extrude it or revolve it as I need. So that's a pretty helpful way to look at things inside of SolidWorks, going from the part level into the drawing level, and then maybe taking it from that drawing level and using it as a way to send it out for quote, send it out for manufacturing, send it out for communication across different file formats. This is also really helpful if you're working with somebody who has a different 3D CAD modeling software. So if I was working in SolidWorks and you were working with Inventor, the way that you guys can communicate with each other might be in a 2D environment with the DXF or DWG. We use the DWG today. You can also save this out, as I can show you as well. You can work with a 3D file format, which if I open up the 98431, if I want to create this as like a IGES file, I can go to File, Save As. I can save this as a IGES file, and this will be the same as if I saved it as a Parasolid, if I saved it as an IGES step, any one of those 3D file types. I'll just save this as a IGES as well, and this is just a little bonus here at the end. It's going to create a dumb solid from the Smart Solid. The Smart Solid is any kind of 3D CAD software with a feature tree where you're controlling the different features and the different sketches that you guys are referencing. If I went to go open this up inside of Inventor from a SolidWorks file, I wouldn't be able to because that native SolidWorks kernel extension file type, which is going to be the SLD PRT, which is the SolidWorks part, can't be opened in those kind of softwares, just like an Inventor native file can't be opened inside SolidWorks. So you have to kind of downgrade it to a dumb solid, and then you have to send it that way. So if I went to File Open, so if someone sent this from an Inventor for me and sent it as an IGES file, I can click on that and hit Open. And what's really powerful about this is it's going to open as the 3D file inside SolidWorks. You're going to notice that your feature tree is no longer filled up with different features and different sketches, but it's just one single solid body. You can actually run and import diagnostics on this part. You can hit yes, and it's going to select all these faces. If you want to repair them, click the green check mark, right click on it, import diagnostics, saying that it doesn't want to be healed, which is kind of unfortunate, but that's fine. It's good reference here though, because even if I can't recreate it, the ultimate goal is if it is a solid part and for whatever reason there was an error, you could actually run a features diagnostics on it and have it rebuild the part as if it was drawn inside SolidWorks. So it tries to remember some of those smart solid aspects, but in this case, it's not going to give me that. But it's helpful because now, even though I don't have the same native CAD software, I can just use this as a way or like a touch off point to send those 3D files. So I hope this was helpful in looking at this from a perspective of, again, creating a 2D drawing from a part, creating a DXF or DWG transfer file from a drawing. You can also create a PDF from that file format as well, and then also sending 3D files either from an IGES file, a Parasolid file, or a step file. So just take that again with a grain of salt, and hopefully that helps you along your way transferring files. So thanks a bunch, guys. We'll see you next time. I'll show you how to create an assembly from this and maybe try to create a mold from this as well.